In the next slide, we'll discuss about the modeling queries, some of the common queries which were raised by our users over the years. How do I center the deck on the bridge support? Currently, if there is an offset between the deck and the bridge support, then when the profile grade does not coincide with the center line of the bridge, the roadway cross section, it can be repositioned using PG offset. And this PG offset option is available in the bridge cross section window, wherein the user can calculate that particular that value and input that value there, and then later on they can reposition the deck with respect to the bridge support. While modeling the bridge using EVC Wizard, if the user tries to input the span details, for example, the bearing offset, the bearing begin offset, the bearing line end offset, the girder clearances for the begin and end. If while doing that, if the cantilever length is greater than the 5% of the beam length, then the program shows a warning message saying that invalid data bearing line offset, as there is a limitation in the program wherein the cantilever length is limited to just 5% of the beam length, and once the changes is done, the warning message goes away. Also, creating a flared girder is quite easy, but if the user wants to have a flared girder on one side, then user has to set the deck width and the related deck offset to the align. So once this is done, if the user clicks on the abutment properties, then the user has to set the length of the support, which is same as the abutment length, and the alignment offset value should be same as the deck offset to align value. So once these changes are done, then the user should be able to create a deck with a flare on one side. So in the next slide, we'll go over the analysis queries raised by the users over the years, some of the common queries raised by the users over the years. The first one, generally in the loads tab, we have some default design trucks which are already assigned under the selected heading. So if the user wants to replace the vehicle under HL93 design live load, what the user has to do is he has to double click on this design truck live load. A new window will appear, which is basically the library. There the user has to select the truck, or the customized truck, or any other truck which he wants to replace. So once he clicks on that customized truck, the current design truck gets replaced with the customized truck. So we have a few analysis options wherein the user can run a girder by girder analysis. We have refined method of analysis. So what are the conditions wherein the user can run girder by girder analysis, and what are the options the user has to check to get it activated? For that, the user has to go to preferences, and in the preferences window, the user has to check this option, girder by girder analysis. There are three conditions which needs to be checked. The first one is the flared girder option needs to be checked. Same number of girder needs to be there in all the spans. At least one of the following two conditions should be met, which is basically related to the beam length. So once all these three conditions are met, the program should be able to run the girder by girder analysis. There are times when the girder by girder analysis does not run, even if the option is checked. As I have mentioned before, for the users to know, the user has to click on the special cases hot link button. So once they click on this button, the three conditions which I just mentioned in my previous slide will be shown, and once these three conditions are met, they should be able to run the girder by girder analysis. So the other analysis is the refined method of analysis, which is basically used to calculate the live load distribution factors. So there are times when refined method of analysis for distribution factor is not available. So what is that the user has to do to get it activated? As you can see in the first screenshot, the refined method of analysis is not available, or it's grayed out. In the second screenshot, you should be able to see the option getting activated. So once the user clicks on F1 key for online help and check feature assumption and limitations, we have few limitations and assumptions which needs to be adhered to get this refined method of analysis to be activated. Some of them are that so this method of analysis is available for only for eye girder, spread box beam, and adjacent box beam. And also minimum 3 girders should be there for the FEM to be set up so that user should be able to run the refined method of analysis. There are cases wherein in the analysis factor window, the refined method of analysis gets grayed out for live load distribution. So in that case, as I mentioned before, there are certain limitations and assumptions which the program follows. So one of the assumptions for live load is that if the bridge is flared, then this method of analysis is not available, and user has to refer to the warning messages which are shown when they try to run the analysis for flared girder. There are some of the users have requested us to know where they can modify the eta factors as per AASHTO LRFT article 1.3.2.1. So these factors are basically the load modifier factors related to ductility, redundancy, and operational classification. By default, we have set these values as 1 for all the 3 load modifiers. If the user wants to modify them or change them or customize them, they have to go to Analysis tab, Analysis Factors, and in the new window, in the Modifier tab, they should be able to input those modified factors there, and they can continue with their analysis and design. So user should be able to apply temperature loads to the girders. So there are times when the program will not show any results for uniform temperature load, and the reason being that for the precast pre-stressed beams are generally simply supported and they're free to expand or contract, and because of that reason in the analysis tab, when they run the analysis, the program will show values at 0 for the temperature, moment, and shear values. So in the previous versions, this new feature was not available. There is an option called DF type in the analysis factor distribution tab. So what is the functionality of this DF type? So in the current release version, we added this new feature. This is basically available for adjacent and spread box beams. The user can designate the bridge type according to AASHTO LRFT table 4.6.2.2.1 bar 1. As you can see in the screenshot taken from the AASHTO code. The bridge type is used for selecting the appropriate formula to calculate the distribution factors. So based on what type of bridge you're trying to model and trying to analyze and design, user should be able to select that particular bridge TF type, and they can generate the live load distribution factors. There are cases wherein generally the girders, the live load distribution factors are calculated as per AASHTO equations. When those conditions are not met, then the program calculates the live load distribution factor as per lever rule. And how do the users will know when the distribution factors are computed with the lever rule? So one of the way the user can figure out how it is, what type of method the program has used. For that, they have to go to the results and generate the report for the distribution factors. And in that particular table, in front of the distribution factors for live load, moment, and shear, if there is any hash sign which is printed, then that means those distribution factors are calculated as per lever rule. Otherwise, if the hash sign is not there, then the program has calculated the distribution factors as per AASHTO equations. For in the analysis, for the when there are composite, there are cases wherein the composite moments of DC and DW does not change, whereas for live load moment it changes for a bridge on a curved alignment. Why would it happen so? For composite loads, DC, DW, and live load are analyzed at the center line of the bridge in conspan. So DC and DW, which are the dead loads, are assumed equally distributed to the girders, which you can see in the analysis factor dialog box. Under dead load and composite, the distribution factors are equally distributed, which can be seen in the screenshot. For live load distribution factors, they are taken into account the girder length, and it varies accordingly, and that's the reason the live load moment keeps on changing for a bridge on a curved alignment.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.